Hello everyone, welcome to this lesson about periodic table of elements. This is the periodic table of elements based on the similarities and properties of elements. Actually, the arrangement of elements according to modern periodic table. The first thing that you have to notice of the periodic table of elements are the horizontal rows, which are actually called the periods. And the periodic table has this wherein the properties of the elements change in a pattern from left to right. As I've explained earlier, that the periods of the periodic table are in actually horizontal rows. So as you can see here that in the animated presentation, these are examples of periods. So you have there going the examples from the left to right pattern. This is another way of showing to you the periods in terms of color coding, and one of the periods here was taken out from the periodic table, and as you can see that the colors are different in each of the periods. So you have a period 1 at the top, going to the second period you have there the orange, the third period is colored yellow, the fourth is green. Okay, you have there below, okay, the color is blue, and dark blue or indigo, which is actually the 1, 2, 3, 4, 5, and 6th. Then you have there the 7th period, okay, the last one, which is color pink. So the 6th continuation of this period is below. Okay, all of those elements that are colored indigo or this uh, actually very dark or get dark blue. Okay, so that's continuation below that. So the pink also, if you can see below, okay, they're all there pink there, and these colors indicates the 7th period. So in all, the periods of the periodic table are actually 7. As I have explained earlier that the periods are actually across the periodic table, so they are arranged horizontally from actually rows 1 to 7. So here okay, you have an example again. Okay, so in the period 1 you only have 2 elements. Okay, the period 2 you have from remember that should be from left to right direction. So you have there the arrows that indicates from that the starts from left to the right. So you have there how many elements? You have 1, 2, 3, 4, 5, 6, 7, and 8. 8 elements for period 2. And the same thing with period number 3, you have 8 elements. And for period 4, okay, so let's count for that. You have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and 18 elements. Okay? So the same thing for period 5 and 6th. And actually for 6th, I mean for the 6th, okay, as I've explained earlier that the this period actually continues at the bottom of the periodic table, and the same thing with period 7. All right. Please remember also that the periods actually are elements have the same number of valence shells. The next thing that you have to observe in terms of the periodic table is the groups or families. These are arranged in vertical columns, and they are corresponding to the number of electrons in the outermost shell. These outermost electrons are called valence electrons. The elements in the group of the periodic table have similar chemical properties. So this is the opposite of the periods, because as I've mentioned earlier, that periods are arranged in terms of from left to the right direction, and this one is vertical column, so that's actually arranged, or you have to uh, take note that to know them is starting from the top to the bottom. So let me share with you the groups of the periodic table of elements. You have here actually the color code legend or indicators. So you just have to take a look at the colors and the names of it. So you have for this color, for example, here you have the violet. So you have alkali metals. For the yellow, you have transition metals, actinides, okay, or you have this orange color, okay, other non-metals. Okay, so you have their light blue and so on. So there are how many groups or families of the periodic table? So you have 2, 4, 6, 8, 10 groups. So uh, it indicates also these groups in terms of the number of electrons are outside the shell. So this actually means that the valence or the valence electrons are those electrons that can be able to transfer or share electrons to other elements, okay, to form compounds. Right? In this example of the periodic table, you can see that it's indicated number or the numbers of these different names, like as I mentioned earlier, or group or families or periodic table. So, for example, uh, the group one or family one of the periodic table starts from the top, which is the hydrogen, followed by lithium, and then the third element for the group one is the sodium. Okay, fourth is potassium, and so on until francium. Okay, which is the last one there. Okay, for the group 1A or family 1A. And so that's the same thing with 2A, so that should start with beryllium, followed by magnesium, you have calcium, and so on. So the same for the rest of the groups that I've was mentioned earlier. You just have to refer in that actually periodic table, or based also on the kind of periodic table that you've been using, right? So the elements from the taller columns, which are the groups 1, 2, and 13 through 18, are called representative elements or main groups of the periodic table. So let's take a look first for the first group. Okay, so this again, okay, the groups 1, 2, and 13 through 18, okay, are called the representative elements. So the group 1 here, for example, the alkali metals again. So you have the lithium, sodium, potassium, rubidium, cesium, and francium. So it shows also the electronic configuration. So of course you're going to learn this as another lesson. Okay? So especially for the higher level or higher grade level. Right, so this is for you to be familiar or to learn first the groups, the names, like those elements that belongs to this kind of group. Okay, so we have here the group 2, okay, of the periodic table, or the uh, family number 2. Okay, so you have these alkaline earth metals. So you have beryllium, okay, so magnesium, calcium, strontium, barium, and radium. Another representative elements, okay, the group 13. So you have these three valence electrons or valence electrons, outer electrons. It means that it loses three electrons to form three positive ions. As this is my explanation last time, or the last from the previous lesson. that I've taught you. So with the start of this group 13, this is a boron group or a boron family. So it starts with the boron at the top. Okay, so next to that is aluminum, and then followed by the next uh, first elements, okay, below. So from the top again, okay, to the bottom first. Next to the boron group, okay, you have the carbon group or carbon family. So yes, this is number 14 there. So that starts with the carbon, of course, and then going down to the of course 1, 2, 3, 4, 5. Okay, 5 of them. And you have here the next one, the nitrogen family. So that next to 13 and 14 of the group. So you have there from the start at the top the nitrogen, okay, and followed by phosphorus and so on. And of course you have to take note that again, okay, the groups or of the periodic table starts from the top to the bottom. Next to that is the oxygen family. Or that will be actually, as you can see, that the 16th, okay, from the group, okay, but then still, as I mentioned earlier, so of course this still, okay, from the top to the bottom, okay, oxygen, okay, going down, okay, to the last element, okay, so you still have there 1, 2, 3, 4, 5 um, 5 elements, okay, for this. And by the way, with regards to the other elements, okay, so you have to take note if there are, based on the periodic table, there are elements that can belongs to the period 6 and 7. Okay, so you have to take a look at that if this oxygen family still have the continuation from these periods 6 and 7. So that still belongs to the oxygen family. Alright, next to that is the halogen family. Okay, so this starts with fluorine. Still the same thing. Okay, the group should starts from the top, okay, to the bottom of that. So this is the last group of the representative elements called noble gases. So you start from the helium, followed by neon, argon, krypton, so of course xenon and radon. This again, okay, from top to the bottom, the noble gases. So this is the last of the representative elements. So remember, as I've mentioned to you, and I've explained to you one by one the name of the groups for the representative elements. And don't forget, you have to familiar or learn a lot for what are those elements that belongs to this group, because it will help you a lot, because it will, you will know the number of valence electrons, okay, so the outer shell electrons. So if you notice that for the group 1, okay, so that's why it's group 1, because you have actually outside of that is the 1, okay, uh, valence electrons, okay, so the 2 actually has 2 valence electrons, okay, that is outside. For the of course next to that, okay, 13, okay, so and so on for the 14 to 15, okay, so you have to take a look at their number of electrons. After the representative elements or groups, you have the next groups called transition metals, or also known as transition elements. These groups belongs the group 3 until 12. So the example here that I've shared with you, look at the periodic table. You have 3rd, 4th, 5th until 12th. So these elements, okay, you have to take a look at that from top to the bottom again because they are in groups. For example, group 3, you have there the of elements that represents, of course, you have the fourth, okay, from the top to the bottom. Please include the lanthanides and actinides for counting and for the groups, okay, of third until to the 12th, right? So in this presentation, you have the lanthanides and actinides series. They are special series of elements, but are also part of the transition block, as I've explained earlier. They are also called the inner transition elements. It is color-coded based on this representation. We have alkali metals and the alkaline earth metals with this light brown color, and the yellow one, which is transition elements, as I've explained also earlier. The noble gases, these are the 18th of grouped. So this is the table of all the elements, as you're going to learn more about the periodic table. And that's color coded for the light red, and you have the blue. Below that, these are lanthanide series and actinide series. So remember, these two series of metals are known as inner transition elements, but note also that they still belongs to the transition block or transition elements. So, and additionally, again, these are the lanthanides of the periodic table, and these are the actinides of the periodic table. Alright, so let me share with you the summary of those you've learned a while ago. The two main divisions that you need to know or learn in terms of the periodic table is that in terms of horizontal rows, so they are called periods, okay, from to the left to the right direction, and from the top to the bottom direction they are vertical, and so they are known as family or groups. And for each group, okay, you have of course individual groups, okay, for this as example here, okay, you have alkali metals, okay, that is the group or family of alkali metals, and you have also the group for the alkali earth metals, okay, so this is the second one. And you have here, for example, as I mentioned earlier, if you look at the 13, okay, so that's the boron group. Okay, you have the 14, you have the carbon group. 15, you have the nitrogen group. Okay, so these are in terms of the numbering. Okay, but in terms of the group, you can see at the top of that's green color: 1A, 2A, 3A, 4A, 5A, 6A, 7A, and 8A. So the if you notice that the color of the noble gases is different from actually this from the other of a group of elements, because they are noble gases. These are special of elements in periodic table. So aside from that, if you notice earlier that the periodic table is also divided into main groups, okay, aside from the individual groups. So you have to remember the transition metals and uh, the part wherein the actinides and lanthanides are also part of that. Okay, so aside from that, you have the representative elements. Okay, so don't forget them again. Representative elements, you have the lanthanides, actinides, okay, so the uh, transition elements. So those are the main groups. Okay, and for the main group, for each main groups have the individual groups. Okay? And what's the functions of the groups is to know how many of the electron shells, okay, or the electrons outside of the elements, for them to share or to accept electrons, and of course to form compounds. So aside from what you've learned a while ago in terms of the groups and the periods, don't forget that the periodic table also have three main groups, another groupings. Like you have the metals, metalloids or semi-metals, and the non-metals. So metals are located on the left side of the periodic table of elements. Most of the elements are metals, so which are solids at room temperature except mercury. Elements that are found far right of the periodic table are called nonmetals, which may be solids, liquids, or gases. Take note, uh, it doesn't mean that nonmetals they are all like liquids. Okay, no. When you say nonmetals, it can also be solids, a liquid, or gases. So stair-step line on the table separates the metals from nonmetals. Okay, so remember a stair-step line. Okay, it's like a stair. Okay, if you can relate that or refer that to the periodic table. The elements along this line are called metalloids. So metalloids exhibit the properties of metals and nonmetals. The seven elements commonly regarded as metalloids are silicon, germanium, arsenic, antimony, tellurium, and polonium. Alright, so as you can see here, these are the things that I've discussed or actually explaining a while ago with you in the periodic table. So on the left side, okay, are the metals, and you have on the right side the non-metals, and of course you have there the like a ladder, okay, of between metals and non-metals. They are the metalloids. So elements that border on the amphoteric line are shown in green are metalloids. They have characteristics of both metals and nonmetals, as I mentioned. Aluminum, however, definitely has mostly metallic characteristics, and boron is mostly non-metallic. The characteristics of metals, okay, as actually you've already learned from your previous years. So metals are actually lustrous, okay, so they are actually malleable and ductile, conduct heat and electricity, and tend to lose electrons. Okay, remember, metals tends to lose electrons. Non-metals are characteristics usually dull. Okay, they are brittle, they don't conduct heat or electricity very well, and tend to gain electrons. So if you notice that metals and non-metals, when you are going to make compounds, they are the best things that can be able to produce. Okay? So because they both can, actually metals can of course lose electrons. Okay, so it means to say that they can actually release. Okay, and then metals can also accept. Okay, so in order for them, okay, to have the balance of electrons outside of their electron shells, and this makes a compound. So are you going to learn that on in the upcoming or the next year level, year level? Okay. Okay, you have to do this simple activity. And so this will help you to achieve a better familiarization of the elements. Okay, so you have there the element name. So you have to put there the exact name of the element, the full name of the element. You have the next column, okay, for the symbol. So you have to indicate there the symbol of the elements. Now you have the group number. So for example, you have the helium. Okay, that's the group number 18. Group number 18. So what's the symbol of helium? I guess it's actually He. So period number. So where do you think is helium belongs to? Okay, in what period, right? Now, you can identify if they are metal, non-metal, or metalloids. So helium. Okay, so what do you think is that? Is it a metal, okay, or non-metal? Okay, or maybe close metalloid like that. So of course you have to refer first this in this activity from your periodic table. Why? Because this still you're still learning or familiarizing or getting to know well. Okay, what's the element name, the symbol, okay, group number like that, and afterwards you'll be very good, or you're going to master the location of the elements. And for example, if we can say francium, so where's francium located in the periodic table? Also, what are the elements that also in line with francium, or in terms of the group and period? And when you talk about the period, take note that these elements have the same properties, chemical properties, or especially with the L number of the electrons outside of that. And when can this element combine with the other elements, or with the other, for example, if this metal to the non-metal and then conform a compound. Okay? So you're going to notice that periods, okay, or groups also help you a lot to identify if the element can share or gain electron to other elements, again, which elements are applicable to combine to other elements in the periodic table, right? So it's if you are going to be a chemist, or maybe you'd like to be a scientist, or perhaps belongs to the pharmaceutical or something like that. So this kind of learning, okay, you need to master them well, okay, especially for the periodic table, right? So you don't just focus on the name of the element. You have to learn also a lot about the group number. Okay, so what are those elements that are also of course the same, almost the same property of that element? Because for example, if in the laboratory you are lacking of an element, and which one do you think can replace this element, okay, which is having this almost the same property? Okay. So that's everything for this. So I hope you've learned, okay, so much. Thank you very much for learning with me. And if you have anything to add, of course, please let me know. Okay, thank you so much, and have a wonderful day.